Welcome back to part 2 of our live training session here with our Subaru STI. In our last tutorial, we focused on building our base calibration file in our VCM editor software. This tutorial, we're going to be focusing on getting the engine to fire up and run and learning how to do the calibration process from start to finish within our mass airflow air calculation mode. So we're going to go through working with the VCM editor and the VCM scanner software and all the things we need to know in order to successfully calibrate everything here in a mass airflow mode. Without further wait, let's jump into our tutorial so we can check this out. Welcome back to our live training session here with our Subaru STI. This tutorial, we're going to be focusing on how to calibrate the mass airflow table. Now, we set up the base map in the last video. We've scaled the MAF table based on a Cobb SF intake using our Excel spreadsheet calculator. So we looked at the stock intake diameter, and then we measured the Cobb SF intake diameter, which is about 2.79 inch. Then we ran it through the calculator. It gave us a renormalized curve. We're going to go then and validate that MAF curve in this tutorial, making sure that the values that we have from the calculator are correct. Chances are we're going to have to go in and modify them. That's not a big deal. We're going to look at that process for both closed and open loop within the MAF calibration curve, making sure we have that dialed in using our VCM scanner. So let's jump in and talk about the specific table we're going to be focusing on for this video. Now, if we jump in here to engine, to airflow, to general, and then into the MAF cal table. This is what we're going to focus on calibrating and tuning. We have our voltage on one axis. The other axis is going to be a direct lookup to the air mass in grams per second that's being ingested into the engine. We need to make sure that this is accurate. This can affect our fuel calculations. It also can affect our load calculations, which are used to reference things like spark timing and the target air fuel. So we need to make sure that the MAF, the values coming from the table are going to be calibrated properly. Once we've changed the intake from something other than stock to an aftermarket, this gets thrown off, and we need to validate that this is actually dialed in properly. So we're going to look at how we can do that, idle, part throttle, as well as wide open throttle. We're going to cover all of that in the tutorial. We're not going to focus on dealing and tuning any kind of spark timing or boost control in this tutorial. We're just going to get our airflow model nailed down, specifically for the MAF airflow modeling. Then we're going to go in the next tutorial, look at speed density, getting that dialed in, just essentially doing our fuel and air modeling. And then we'll take a look at doing boost control and spark tuning in a separate tutorial, just so we can keep the process straightforward and streamlined so you're able to replicate this on your end of things. So the base file, again, we've created it. Everything should be safe, conservative to start with. We've lowered the boost down. We lowered the spark timing down, so we have less than ideal spark timing, less boost than we want to run. That's fine. We're going to be focusing on just dialing this in. So the very first thing we need to do is jump into our VCM scanner, get our engine fired off, and start to take a look at how the engine is running in closed loop conditions. Now, what we want to have open here, I have my channels list. Go to File and Open. We want to go into and have the SD tuning channels. That's our channels right here. Now, this is specific for speed density based tuning. I have all the channels that I need to log and take a look at. This can actually log speed density and mass airflow tuning. We're actually going to take a look at both here, working with this. So this is going to be a solid logging list that you're able to use. You definitely want to have this open for doing this next process. So that's found in the course packet right into the channels config. You can actually go here to File, Open. If we go here to Open Channel Config, we should be able to find this if we take a look into the course packet under Desktop, HPT Subaru Course, and then in here to VCM Scanner. And in this case, I actually don't have them saved in my folder. They will be in your folder, but that's going to be the location of them. I have them saved in a different folder here on my laptop, which I'll transfer by the time you actually go in and you're watching this tutorial. Everything will be neatly found in folders inside of our main Subaru course folder. But that's going to be the channels list you want to load. The next thing we have here is the layout that's specific to what we want to take a look at here. So we have our histogram and we have our chart versus time. For this tutorial, we're really going to be heavily focused on our histograms, our MAF closed loop error, and our MAF EQ area. Now the MAF EQ error is going to be taking a look at the lambda from the lambda target tables, and it's going to be taking a look at the lambda reading from our wideband gauge. Now you could use air fuel error if you wanted to, but I like to tune in the units of lambda. It standardizes the process. We had a video talking about air fuel and lambda relationship in the training course. You should understand how they're related, but I choose to work with lambda. So the EQ ratio error here is based on your lambda registration reading. We're going to have our equivalent ratio commanded, which is our commanded lambda, commanded target air fuel. coming out of the ECU, then it compares it against, in this case, I have a wideband wired in. I have a ProLink cable that allows me to wire the 0 to 5 volt wire from my AEM wideband into my ProLink cable, and then I set that as a transform function. We talked about this in the training course, but let's cover this real quick. So I selected this as a channel, my MPVI ProLink coming onto my input 1, and then I've set the transform to transform the voltage to a lambda reading under transform under equivalent ratio, and then I selected this particular transform. So we see it takes the voltage from the wideband coming in the ProLink cable, the 0 to 5 volt output from the wideband gauge, it translates that into a lambda reading. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.